Let us start lecture 4. So this is the last part for the mid-semester exam. So mid-semester exam would be lecture 1 to 4. Before we start this lecture, could you please go to the Blackboard, Learning Resources, lecture 3, then lecture 3 revision questions. So if you could go back to your Blackboard, Learning Resources, lecture 3 revision questions. So let us spend around 7 minutes trying to answer. So for those workout questions, you don't need to do it until the final answer, but if you put the mathematical expression, it would be fine. You don't need to calculate every step, but for instance, the first question you would find this one. So find the confidence interval. So if you could put the numbers, again, the critical value. So confidence interval is point estimate plus minus critical value times standard error. So confidence interval times standard error is the margin of error. So please, you don't need to write these things because it is on Blackboard. So if you could go to Blackboard, Learning Resources, and then lecture 3, then you will find lecture 3 revision questions. So please let us spend around 7 minutes trying. I have 6 questions which I prepared as a revision question. You don't need to answer the final answer, but if you try to show me the steps, for instance, what is the critical value, that's important, and how do you calculate. So important thing is how to calculate how to find the critical value from the table, because confidence interval is point estimate plus minus critical value times standard error. The critical value times the standard error is the margin of error, or you could call it the sampling error. So please let us spend 7 minutes. So out of 6 questions, probably 2 questions are multiple choice questions. So for those multiple choice questions, you could choose whichever you think is the correct answer. But for the other questions, you just simply try. You don't need to answer until the final because we don't have much time. But what is important is just pick the numbers, put in a formula, and that the calculation, you will do it later. So type of question, the first thing that you have to think is that whether the population standard deviation is given or not. What do you think in this question? Is the population standard deviation given or not? What do you think? Is it given or not given, the population standard deviation? Is it? Not given. So we have to apply Z or T. And if we apply T, in order to find the critical value, what do we need? We need degrees of freedom. And the degrees of freedom is N minus. Why it is minus 1? Because we are only talking about one sample. If I had 2 samples, for instance, this group of students and this group of students, 2 different samples, then N minus 2. But we are only talking about one sample. So X bar plus minus critical value times the standard error. Don't put the answer until you don't need to put the final answer. If you have the intermediate answer, that would be fine. So what is the point estimate plus minus? What is the value of the critical value? And how do you calculate the standard error? If you have those things, then you don't need to calculate until the end. Okay, let us try to do together. So as you could see, the population standard deviation is not given. It is the sample standard deviation. So we have to find the T critical value. If confidence interval is 90%, what is alpha? Alpha is 10%, 5 to the right, 5 to the left. So 5% on the right hand side and 5%. Always confidence interval is a two-tail test most of the time. So this is the information given, 59.4, the sample standard deviation, 90% and 120. How many degrees of freedom do we have? How many degrees of freedom? 119, n minus 1 degrees of freedom. So you need this n minus 1 degrees of freedom, alpha 10% alpha, alpha divided by 2, it will be 5%. So T 0.05. I went to the table and I found this one. The rest is a matter of calculation. The important thing is how to find this. So degrees of freedom, 119, and alpha divided by 2 is 5%. So the population mean would be somewhere, we have 90% confident that the population mean would be somewhere between these two values. We don't know the population mean, but we could estimate. So the estimation of the population mean would be somewhere between these two numbers. The closest T alpha divided by 2, this is what I found, 165, because in the table, if you are doing it using software, it will tell you exactly. But if you are using the table, maybe you might not find exactly 119. So you have to take 120. For instance, 5% to the right, 5% to the left. So I chose the 5%. And then the closest is 119, is 120. So this is my critical value, 1.6577. So I use 1 with plus and then with minus. So 1.6577. So that is the answer. Let's go to discussion. You are opening up a shoe store, and information about people's shoe size is important in order to estimate how many shoes of each size to order. Assume studies have shown that people's shoe size is normally distributed with a standard deviation of 194. Here, is population standard deviation given or not? It's given. Do we apply T or Z? Z. 98%, alpha is 2%, to the right, 1%, to the left, 1%. Sample mean is given, so this is the information which is given, 98%, and 20, we have to find 0.01. So 98% means alpha is 2%. On the right hand side, there is 1%. On the left hand side is 1%. So the best thing to find Z value, you go to the Z table and find 0.01, the 1%. So I found 2.33, 98% confidence interval. The remaining is 2%, 1% on the right, 1% on the left. So the population mean would be somewhere between this and this. So the shoe size that you need to order would be somewhere between these two numbers. Now, how could we find this 2.33? So on the right-hand side, we have 1%. On the left-hand side, 1%. The easiest is to find on the left or on the right? Which critical? On the left, because it is always Z value the left. So I am trying to find the left one, the negative one, the left one. I am trying to search for 0.01 here. 0.01 is, this is the nearest, 0.01. So minus 2.33 and plus 2.33. So 2.33 is the critical value. Because we are doing confidence interval, we are doing plus, and we are doing minus. So the easiest is always to find on the left-hand side because the table always tells us on the left. 1% on the left. If you want to find the right side, what probability do you have to look? 90? 99. So you have to search for 99. Okay, let's go to the third question. A friend of yours is considering running for a mayor and is asking you to help him finance his campaign. Before you agree, before you said, okay, I will give you money, or said, no, I will not give you, you decide to randomly sample 70 people about their voting intention, and you found out that 29 of them are happy to nominate your friend. Now you construct a 95% confidence interval. My question is that this is for the mean or this is for the proportion? This is a question of proportion, and we have to apply. If it is always proportion, do we apply Z or T? Always we apply Z. 95% confidence interval, 5% is alpha, 2.5 to the right, 2.5 to the left. What is the critical value? The critical value is 1.96. So please don't forget, 90%, 1.645, 95%, 196, 1%, 2.575. If you could memorize somehow these three, because usually 1%, 5%, sometimes 10%. Okay, now P hat, this is the sample proportion. People voting your friend, 0.41. The rest would be Q hat, which is 0.58. 95% and 70. This is the formula that we use. 0.4143 plus or minus critical value. Then P hat, Q hat. P hat is 41. Those who vote, those who don't vote your friend. Then finally, you found between 30% and 53%. Now keep in mind this one, because I will use the other slide. Please write this one, 30% and between 30% or 29, 89% and 52, 97%. If an election happened today, there is a probability that your friend will be elected with this somewhere in between. Now there is a second question which is following, based on, keep this one in mind, 30%, 53%. Now let's continue to the other question. Question B is saying that, so the critical value is here. Question B, if there are 5 candidates in the race, should you finance your friend's campaign? Would you be happy to finance? If there are 5 candidates, would you say yes or no? Would you be happy to finance or not finance? And then justify your answer. Do you say no because you don't like your friend, or yes or no? What is your confidence interval between? The confidence interval is between 30% and 53%. If 5 people are compete, what is the probability that you would win? If there are 5 people, the probability that you will win would be? What is the probability? If there are 5 people and 1 person has to win, what is the chance? What's the percentage? 20%. If you are going for a job interview and there are only 2 people shortlisted, your chance is 50%, because there are only 2 people. If there are 5 candidates, your chance of winning would be 20%. Your confidence interval tells you between 30 and 53%. Would you be happy to finance? Yes, you would finance, because without financing the person, without doing anything, that candidate has a 20% chance. But if you finance, his chance would grow to between 30 and 53%. So you would be happy to finance the candidate, because without even financing, he has a chance of 20%. But if you support, his chance would be far beyond that. So you would assume that he would be, definitely there could be 1 person who would take the 90% and the rest 4 candidates might not get anything. But if we are thinking of probability, your friend has a 20% chance of winning without any kind of help. But if you help, he would get between 30 and 53%, far above. So, if there are 5 candidates, then the probability that your friend will win the race is 20%. However, our result shows that we are 95% confident that between this of the population of those who are eligible will be voting for your friend on election day. So the answer is yes, you should finance your friend's campaign because the probability of winning is high based on your research that you did. You take a sample, you did your own confidence interval, and the confidence interval is above the 20%. If there were only 2 people, maybe you might hesitate, because this would be 50%, and there is a probability that it could be 30 also, or 32, or 33. You are not quite sure. So you might be thinking, oh, if there are only 2 candidates, maybe I will not finance you, even if there is a little bit chance here, but it could be also somewhere here. Okay, let us assume that Best Buy collected a pilot sample of 50 customers, pilot sample, and found that 8 were female. If the company's manager wants to be 98% confident of estimating the proportion of female customers to within a sample error of plus or minus 0.05, what sample size do we need? Is this one sample size about the mean or proportion? Is the question is something to do with proportion or with the mean? It is something to do with the proportion, because 8 out of 50. We have the formula for the proportion, if you remember, how to find n. 98% you have to find from the table, from the Z table. So this is, the p hat is 8 divided by 50. By the way, I gave you last week, there are 3 different methods. Method 1, method 2, method 3. Method 1, you depend on historical data, isn't it? Method 2, you use P 0.5, Q 0.5. Method 3, you apply a pilot study. So this is method 3 because you are doing a pilot study. Okay, so this is the information. This is method 3. So this is, you have to find. And if it is 98%, what did we find in this question? Sorry to take you back. 98%, I had a question somewhere. 98%, so 2.33, isn't it? 98% with Z, 2.33, so it is, we can. Okay, so this is 98% minus 2.33, 0.16, your pilot, 8 out of 50, 0.84 Q. E is the margin of error. The sampling error is plus minus 0.05. The formula is square. So what is the required sample size? The required sample size is equal to 292. Always an integer. Always. Don't go back. Always, whenever you have decimal, then the next integer. So the required sample size is 292. Okay. In constructing a confidence interval to estimate the population mean with a known population standard deviation. Known standard deviation means the population standard deviation is given. Which of the following does not affect? Which one do you think doesn't affect? Which one of these 4 doesn't affect the width of your confidence interval? Someone saying something. What was that? Sample? Sample size? Sample mean? Yes, the answer is sample mean, because this is the formula. This is the most important. The width would be determined by plus and minus. It doesn't matter this, it could be 10, it could be 20, but the width, how far you go negative, how far you go positive, will be determined by all these factors. So these are the determining factors. the critical value, the population standard deviation, the sample size. This X doesn't, because the width means the plus and the minus are the important. Okay, let's go to the final question. Assume the population standard deviation is known. Which of the following would most likely result in the widest confidence interval? Which one would give you a wide confidence interval? So I think the easiest way to do this one is I just simply created a hypothetical example. You could have a hypothetical example. So the answer is, I think, it's B, but I created a hypothetical example. What small sample mean and what large sample mean. The population standard deviation is given. So I just simply assumed that, okay, this is given, let's say 20, given. The small for me is 16, large, let's say 100. You could give any number, but you have to differentiate small and large. Now let us apply this one. Small sample size is 16. Alpha is 5%, so 2.5 to the right, 2.5. So I calculated using that. 1.96, 20 is given, and 4 is the square root of n, small sample size. So I'm calculating this, because this is the most important, determines the widths. The widths will be determined by this one. I calculate for the second one. 0.01 means critical value 2.575. Small sample is 16. The square root of 16 is 4. This one is given. I just simply, hypothetically, I created any number. You could have any number. I did the third one with large sample size. So the same thing, only this one changes large sample size, 10. And the last one is. So B is the correct answer. You could create any hypothetical example. And the sampling error is 12.88 for this example. So it would give us the widest. Okay, so if you remember, we did a confidence interval last week. This is an extension of that, but it is hypothesis test. So whether we would reject our claim or not, or somebody's claim. So they are all the same. Last week we tried to estimate the confidence where the population mean would be. We estimated where the population proportion would be. Today we are testing our hypothesis, whether to reject our hypothesis or not to reject our hypothesis. So I'm giving you one example. Consider the case of this bottler. They always produce half a liter of beverage or whatever it is. But always when we buy soft drink, or when we buy a bottle of water, sometimes it is full, sometimes it's not full. There is always a variation. So this company has two concerns. For instance, if we are always getting full, what does it mean? Or let me put it that way. There is a bottle of 500 milliliter of soft drink. But always when you buy, it is not really full. It is somewhere between a little bit more than half. What is your feeling? What is your feeling? The feeling is you are cheated. You are paying money, but what about it is too full? Then the company is losing some money, isn't it? So you want to test this one. And this could happen because the machine may be not working properly. The machine wears and tears, then sometimes the machine, there is a specification of 500 milliliter, but the machine is not working correctly. So you as a manager, you have a concern. What do? You would not simply count everything that you produce and measure. You take a sample of soft drinks, and you measure. Let's say if you find the mean is 498, what would you conclude? You take a sample, you measure, and then you found 498. Would you say that's fine? Or let's say if you find 450, what do you say? Would you say the machine is fine, there is no problem with the machine? Or you would say that there is a problem? For instance, we shouldn't simply decide based on the sample. We take a sample, 498, oh, there is no problem. We shouldn't decide that way. Why? Because there is sampling error. Okay, yours is 498, but if I take a sample, it could be 450. If another person takes a sample, maybe 470. So we shouldn't simply decide because we take one sample, because there is sampling variability we mentioned last week. So we have to follow certain criteria. And to do this, we have to use null hypothesis, alternate. So we have to go through the process. But this is what managers, what everybody is doing. You randomly select, you measure your sample mean, you have some hypothetical, your claim is 500. As a manager, you always advertise, we sell 500 milliliter, $3 each or something. So that is your claim. But you want to test your claim because you are feeling that your machine is not working properly. If it is underfilled, you are really cheated. Consumers are cheated if we are getting less than 500. If we are getting a little bit more, then it is a cost for the company. So they want to know. So they take a sample. As I told you, there is a sampling error. You shouldn't simply compare. In situations in which you need to test a claim, the claim is 500 milliliter, about a population mean, by using the sample mean, you cannot simply compare. You cannot compare 498 of your sample mean. You cannot simply compare the sample mean to the claim and reject the claim if sample mean and the claim are different. You need a procedure to follow. Okay, so let's go through the procedure. In this case, also this is a cereal. It is 368 grams, the claim of the company, but we have to follow certain procedures. And this is what we call, we have to create null hypothesis. Null hypothesis is what is the claim, the alternative hypothesis, the opposite of the claim. You want to prove or disprove. So this could be, for instance, one kind of hypothesis test. This is the claim. The cereal is 368, but you could say that, no, it's not 368, it is different. Sometimes if you feel that it is more, then you could change this one. But we don't know. For instance, in terms of these 500 milliliters of soft drinks, sometimes full, sometimes not full, sometimes half, sometimes more, you don't know. So the claim is 500 milliliter. Because you are not sure, sometimes underfilled, sometimes overfilled, you say that it could be either way. It could be more than 500 sometimes, it could be less than 500, because you are not sure. But if you are always getting half, 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 then you think that, no, it is always less. But in this case, if you are not sure enough in which direction it is going, then this is what we call a two-tailed test. We will come to that, because there are three different hypotheses. One tail to the right, one tail to the left, or a two-tail. So we have to know the null and alternative hypothesis. The null is the status quo, which means nothing is happening, everything is fine. There is always 500 milliliters, there is no problem. If there is something really happening, it is just due to chance. So there is nothing to fear. The 500 milliliter is fine. The machine is doing fine. If there is a little bit deviation, that is just simply due to chance. That is what you are saying in this status quo. You will not reject that claim, this claim, you don't reject, unless and otherwise you find a convincing evidence. How do you find the convincing evidence? We will do it together. So the null hypothesis is saying that nothing new or interesting is happening. The 500 milliliter is still fine. I thought that the machine is not working, but it is fine. If there is a little bit difference, it's just simply due to chance. Then the opposite of that, so always the null hypothesis must have an equal sign. Equal sign. So there are three types, as I told you, but the equal sign must be always in the case of null hypothesis. The null hypothesis, nothing is happening, there is no difference. Chance is a good example. There is no statistical difference. We will come to that. The alternative is the opposite. That is what the researcher wants us to know. That is, for instance, a company is saying something, then there is a testing agency. A testing agency would come, take a sample, and then They want to make a research. So we have to apply is not equal, greater, or less. So there is always inequality sign. Alternative hypothesis, inequality sign. Null hypothesis, equality sign. There is equal, there is equal. In the case of alternative hypothesis, we call it a researcher's hypothesis because you want either to reject the claim or not to reject the claim. You don't say accept the claim. Either you reject it or you don't reject it. If you don't reject it, you are saying, I didn't find enough evidence. But you are not saying I accept. So what is the alternative hypothesis? Something is really happening. If you reject the null hypothesis, you are saying something happening. There is a difference. You are telling me 500 milliliter, but I found that there is really a difference which is really significant. So where do we find the population mean and the population standard, the population proportion? We don't know. We just simply hypothesize. Sometimes past evidence would tell me to hypothesize. Sometimes a theory would help me, but sometimes specifically design specification. Design specification means when you open your company, you designed a bottle for a 500 milliliter. So that is design specification. That is your hypothesized value. If I am a manager of that bottle, my hypothesized value is always I am selling 500 milliliter to any customer. But at some point my machine could be not working properly, so I doubt and I do my research. So the design specification in terms of cereal, in terms of bottle of water, in terms of bottle of milk, this is the design specification where the manager wants. So we don't know the population mean, but we are hypothesizing the population mean. If we know the population mean, there is no point. There is no point doing all these things. We take a sample because we don't know the population mean. Through the sample, we want to talk about the population. We want to say something about the population using our sample. So as I told you, your alternative hypothesis would be less. For instance, if you are believing that, no, we are always getting less soft drinks, less than 500 milliliter. This is the best hypothesis. You say less, but the null hypothesis, the status quo is either equal or greater. If you are feeling, oh, this company is always selling me more than 500 milliliter, that is what you suspect, then you do it one tail test. If you are not sure enough, because sometimes you might feel that the machine is giving more, sometimes underfilling, sometimes overfilling, you are not sure which way to go, then the easiest one is the not equal. Which one do you think is the safest in terms of alternative hypothesis? The safest one. The first, the second, the third. The third one. Because if you are not sure enough, it is better, it could be this way or it could underfilled, overfilled. You are not sure enough. But if you have a very concrete idea, oh, every customer is getting less, then you hypothesize this one. What is the difference between this and this? Definitely alpha. Here you divide alpha by 2. But here you don't divide alpha. The alpha would remain the same because you are doing only one tail. Okay, so this is one tail upper, one tail lower. So either we reject the null hypothesis or we don't reject the null hypothesis. As I told you, we don't say we accept the null hypothesis. I will give you an easy example about that, which probably might not be in your... So these are the steps that we have to follow. 7 steps that I put, but you could put it in 5 steps. The first one, null and alternative hypothesis. Null and alternative hypothesis, step 1 and 2. The third one, the significant level. This must be given. The level of significance, what does this mean? You reject the null hypothesis while it is true. You reject the null hypothesis. I reject this one while it is true. I make a mistake. And my mistake is 5% or 1%. I shouldn't put alpha 20%. My mistake must be very low. So alpha means you reject the null hypothesis. You reject this hypothesis while it is really true. You make a mistake. And that mistake, we call it alpha. Usually we put alpha 5%, 1% for the mistake that you do. because always we can make a mistake. The same thing, a judge, when the judge sentences 20 years, he could make a mistake somehow based on the evidence presented to him. Okay, so two direction, as I told you, this is two direction, on the right, on the left. This is one direction to the right, upper, one direction to the left, lower. So null and alternative, calculate the appropriate test statistics, either Z calculated value, T calculated value, or test statistics. So this is the Z or the T. Find critical value from the table, make decision, and make conclusion. These are the steps that we have to follow. Please, in your exam, I will ask you one question from this lecture, or two, depending. So you have to follow these steps, because for each step you will get mark. So level of significance, we call it type 1 error. Why? Because I am rejecting the null hypothesis in favor of alternative hypothesis, when in reality the null hypothesis is correct. The null hypothesis is correct, but I rejected it. I make a mistake, and that mistake we call it type 1 error, and that is alpha. Alpha is type 1 error, the mistake that I do by rejecting the null hypothesis when it is really true. It is true, but I rejected it. Okay. The test statistics, this is simply that what you calculate. This is what you would calculate. Using the formula, you will calculate the calculated value. And this is from the table, the critical value. This is what you get from the table, and this is what you calculate. Then the rejection region, then either you would reject or you would not reject. So either you reject the null hypothesis, always the claim. You reject, most of the time the claim is null hypothesis, but some instances, sometimes the claim could be the alternative hypothesis. But overall, in most cases, the claim is the null hypothesis. That's why we call it the status quo. Nothing is changed. He claims that it is 500 milliliter. The person claims it is 368 grams of cereal. So, now I came to that one. Not rejecting the null hypothesis does not mean that the null hypothesis is correct. You don't reject it. If you reject it, it is null hypothesis is incorrect because you reject it. If you don't reject, you are not saying that you accept it. What you are saying that fail to reject the null hypothesis, then you can conclude that there is insufficient evidence to warrant the rejection. So let's go to one example. Probably it's not in your slides, but anyway, once I finish, I will give you my slides. Yeah. So let's go to one example. When a person is accused of crime, he or she faces a trial. The jury must decide the verdict in the same way that a statistician draws a conclusion about a test of hypothesis. The case begins with null and alternative hypothesis. The defendant is innocent, the null hypothesis, nothing is happening, the status quo. Alternative, the defendant is guilty. The jury does not know the truth about the hypothesis. They must, however, make a decision based on the evidence presented to them. And for us, based on the sample. And here, based on the evidence, the police evidence, the whatever evidence, the video evidence, CCTV evidence. So, if the jury finds that there is enough evidence to support the alternative, then the defendant is guilty, rejecting this one and sending the person to prison because there is enough evidence. If you don't have enough evidence, you don't say that the person is innocent. What you would say that I didn't get enough evidence. You wouldn't say that you are innocent. But the material presented doesn't allow me to consider you as a guilty person. If the jury finds that there is no enough evidence to support the alternative hypothesis, then the jury renders a verdict of not guilty. He would tell the person you are not guilty. He's not saying that you are innocent, but he is saying you are not guilty. Who knows, after a year, some evidence could come because he is not told innocent. He is not guilty for that particular evidence. Not guilty. they don't conclude that the defendant is innocent, but he is not guilty based on the evidence presented. And here what we do is the same way. We are doing I'm innocent. Yeah, so they don't conclude that the defendant is innocent. What they say that not guilty. They don't say innocent because the defendant is not necessarily innocent, just that she hasn't been proven guilty by the evidence presented. That's why we never say accept the null hypothesis. We say we don't reject the null hypothesis. Okay, now let's go to the example. This is simply a two-tailed test. Assume that the population standard deviation is given. This is how we calculate the test statistics. The test statistics is this one. The test statistics. This is null alternative hypothesis. Test statistics, alpha has to be given. Alpha is given 5%, two-tailed test. The hypothesized value is 100. I put here 0 because it is not actually the population mean. It is the hypothesized population mean. Because if we know the population mean, there is no point of doing all these things. So we know that 5% alpha, to the right, to the left, 1.96. This is the rejection area. This is alpha divided by 2. This is alpha. This is the non-rejection area. This is a two-tailed test. Equal, not equal to 100. Let's go. So how do we? If I calculate here, let's say I found 2. My calculation saying 2. This Z calculated equal to 2. So 2 is somewhere here in the rejection area. So I reject the null hypothesis. Or if I calculated minus 3, minus 3 is somewhere here. So I reject the null hypothesis. What about if my calculated value is equal to 1? Equal to 1. 1 would be somewhere here. Then my conclusion would be, my decision would be, I don't reject. And your conclusion? If you don't reject, what is your conclusion? There is insufficient evidence at 5% level of significance to conclude that the population mean is different from 100. You see, always you have to mention that 5%, the alpha, because you have insufficient evidence based on this 5%. You might have sufficient evidence based on 10%. Okay, then if greater than critical value, and this is the example I gave you, 2, minus 2, or absolute value. You don't care about the negative values. This is what I am doing is the critical value approach. There are two approaches, critical value approach, the p-value approach. We will come to the p-value. This is a critical value. Another example, one-tailed test. Greater, less, or equal. Again, 5%. So the whole 5% would be on the right direction because this is greater. So how does it look, my graph? Because 5% one tail would be 1.645. This is the whole 5%. So if my calculation here is 1.9, 1.9 is somewhere here, I reject the null hypothesis. If it is somewhere here, I don't reject the null hypothesis. So if my calculated value greater than this one, I reject. The third one, the same example, let's do to the left. Now to the left, one tail to the left. Again, 5%. The whole 5% alpha must be on the left-hand side. And we know that from our experience that 5% one tail is minus 1.645. Again, if this one is somewhere here, I reject the null. So minus Z critical is greater than this value or less than this value actually. So you reject, it must be less than this one. In order to reject, minus 2 is here. Minus 2 is less than this one, so it must be less. So this is the thing that we have to do. We will do with the mean, we will do with the proportion. We will do using critical value, we will use using p-value. So the whole exercise of today is nothing more and nothing less. We do a hypothesis test for the mean, hypothesis test for the proportion. We make our decision using the critical value approach. We do also using the p-value approach, which is almost the same. Now, the p-value, let me take you back. Let me take you to this example. What would happen if my calculated value is 3? 3 would be located where? 3 would be here. The probability 3 and above, do you think, so the probability 1.96 and above is 2.5%, isn't it? From here until the end is 2.5%. But if you calculate here 3, what would be the probability? Less than this one or greater than that? It has to be less than. So in the p-value, a small p-value is important to reject because I calculated 3. Here I calculated 3. I said, oh, 3 is in the rejection area, so I reject the null hypothesis. In other words, you are saying from this 3 to the right is less than this one. Because from 1.96 to the right is 2.5%. From minus 1.96 to the left is 2.5%. What about from 3 to the right? Would it be less than 2.5% or greater? From 1.96 to the right is 2.5. From 3 to the right would be less. So a less p value is important to reject. And a big z value we need to reject. In terms of critical value, large value is good. In terms of p value, a small p is good. Okay. So let me show you that the p-value approach. So this is the previous example, two-tailed. I have one information which is not in your lecture note, but I will. From the above picture, a hypothetical example, we know that the area to the left of minus 1.9, 2.5%, to the right, 2.5%. Now, let us make some hypothetical example. Alpha, what is alpha? How many percent is alpha in this example? Alpha is, the type 1 error is 5%. I can reject my null hypothesis while it is true. That is the type 1 error, okay. In this example, we know alpha is 0.05. Let us hypothetically assume if the z calculated value is, let's say, greater than 2.10, or if it is minus 2.10. This is hypothetically, my calculated value here is 2.10 or minus 2.10, any one of the two. 2.10 minus or minus 2.10. What do you think about the p-value for the test? Is it greater or less than alpha? Less than alpha, because it must be less than alpha. The probability greater or equal than 2.10, I went to my table, because the less one is the easiest. I went to my table, and then I found in my table minus 2.10 is this percent. So I have here I have 2.10, I have minus 2.10. From 2.10 to the right, 2.10 or to the right, I found 1.79%. And again, from minus 2.10 to the left, I found the same probability, so I have to add both of them. Why do I add them? Why do I add them?
Because you are divided the alpha value, so now you have to add.
Yeah, so because we are doing two tests. If you are doing two tests, the probability, the p-value must be multiplied by 2. If it is a one-tailed test, then we don't need. So 0.05358 is less than alpha. That's why we reject the null hypothesis. What does p-value really mean? What does p-value really mean? The p-value is saying that the probability z greater or equal to 0.10 plus the probability z less than minus 2.10 given that the null hypothesis were correct. If the null hypothesis were correct, what is the probability of these two? The probability to be on the right-hand side of 210 to be on the left-hand side of minus 2.10. What is the probability? Given that the null hypothesis were correct, assuming the null hypothesis is correct, what is the probability to the right of 210 to the left of minus 210? We found the probability is very small. It is very unlikely these things to happen. So I don't trust the null hypothesis because the probability that I found is very less. It is unlikely that these things to happen. So you ask yourself, where is the problem? Why do I get a small probability? Either I have a problem with my sample or the claim is wrong. I trust my sample because it is randomly taken, a random sample. So there is no problem with my sample. The problem is the claim was not correct. So I explain about this when we do the sampling distribution. If you remember, 30 and 33. I don't know what the example was about, but we use the pizza delivery. The pizza delivery 30 and 33. So assuming that the null hypothesis were correct, the probability that I would see these things is really unlikely. If it is unlikely, where is the problem? Either the problem is in your sample or the problem is the hypothesized value was wrong. The person who claimed, he is not telling me the truth. So we trust usually the sample because it is a random sample that we are taking. But the claim is there is something with the claim. That's why we reject the claim. That's why we reject the claim. That's why we reject the null hypothesis. So I am trying to explain the logic behind p-value. Otherwise, you would understand once you have this value. You would say that you reject the null hypothesis. But what does p-value mean? P-value means that assuming the null hypothesis, assuming the claim is correct, what is the probability of seeing above this and below this? And then I found very less, unlikely to occur because the probability is less than alpha. You ask why? Then they say that the problem is probably the problem is here. The hypothesized value was not correct. My sample is still correct because I do it randomly. We assume that we do things randomly. Okay, I will give you a little bit example, then we will have a break. Again, this is, please don't worry when I say that it's not in your lecture note. I just want you to explain before you see the slides, because if I give you the slides, maybe you might be confused. So I would like to explain myself, then I give you the information, so you digest yourself. Keep in mind okay, then this is the whole thing. Maybe I will come later, it's not here. So if the p-value is less than alpha, we reject. The p-value is less than alpha, we reject the null hypothesis, the p-value approach. Then if you are doing a two-tailed test, the same thing like what we do a two-tailed test, you have to multiply. So I multiply this one by 2, or you add them, because there is a possibility to this direction, a possibility to this direction, you add both of them. However, if the p-value is greater than or equal to alpha, greater or equal to alpha, you don't reject. You don't reject the null hypothesis. The same thing in a one-tail upper, p-value less than alpha, you reject. The same thing in the case of lower tail, p-value less than alpha, you reject. P-value greater or equal to alpha, you don't reject. Always p-value must be less than alpha. Please don't forget, in a two-tail test, you have to multiply by 2. The same way that I did here, multiplied by 2. Greater than 210, greater or equal, I found 1.79%, 1.979%. I add both of them, then my p-value is. And don't forget, please, because sometimes it is confusing, the p-value, if I ask you in a multiple choice, the interpretation of the p-value, given that the null hypothesis is correct, the probability that I will see this kind of things is very small. And because of that, I would say that there is a problem with the null hypothesis. So I reject the null hypothesis. the claim was not correct. Maybe the person is exaggerating, or maybe depending on the type of the question. Okay, let's stop here. We will start if the population standard deviation is given, if standard deviation is not given. Here we will do for the mean, for the proportion, and here we do for the mean. Here, mean and proportion. Okay, let's have around 7 minutes of break. Okay, let us continue. So, here, population standard deviation is given or known. We could use for the mean as well as for the proportion. Here it's only for the mean. Or for the proportion is always Z test. Okay. Population standard deviation is given. Let us say a two-tailed test. 25. The claim is 25. Then you are saying it's not equal to 25, the alternative hypothesis. You take a sample of 57 observation. You got 28.1 sample mean. Population standard deviation is given. 1% level of significance. If alpha is 1 to the right, how many percent do we have? 0.5% to the right, 0. So alpha divided by 2 to the right, to the left. It is a two-tailed test because this is not equal. So we have to find out 1% two-tailed test. So the calculated value is mean minus the hypothesized value. This is the hypothesized value. Everything is given. We found 2.77. 2.77 in this one. I found the critical value from the table. If you go to the table, 1%, both tails means 0.005 and 0.005. If you add them, so 2.77 is in the rejection area. Because the test at 2.77 is greater than the critical value, than this one, in the upper tail, we are talking only about this because we don't have figures, then we reject the null hypothesis. What is the decision? The decision is we reject the null hypothesis. The conclusion, there is sufficient evidence at 1% level of significance to conclude that the population mean is not equal to 25. So always, please conclude about the alternative hypothesis. So there is enough evidence, there is sufficient evidence at the 1% level of significance to conclude that the population mean is not equal to 25. Now my question, at 1% level of significance, what is your decision? Your decision is reject. What about if it were 5%? You give a chance of a mistake 1%, you reject. If you give a chance of a mistake 5%, you reject. At 10%? Now let me put it the other way. If this were 5% from the very beginning, you reject at 5%. What about at 1%? We are not sure, may or may not. What about at 10%? You reject. So if you give a chance 1% and you reject, if your chance is more, then you could still reject. Okay. Now, let us apply p-value approach. The p-value approach, do we have to multiply by 2 or no? The p-value approach that I use here, did I multiply it by 2? Why do I multiply it by 2? Because it is a two-tailed test. So let us do the same way. Because here, if you remember, the p-value for the two-tailed approach need multiplication by 2. So, alpha 0.01, two-tailed test, the test statistics 2.77. We know that the area to the right of 2.77, the same to the left of minus 2.77, isn't it? The area from here to the right, the area from minus 2.77 to the left is the same. So, it is easier for me to check in the table for the negative Z value or positive Z value. For the negative Z value is easier. So I went to the table, minus 2.77, minus 2.77, 77. I found 0.028. Do I have to multiply by 2? Yes, I have to multiply by 2. Why? Because we are doing a two-tailed test. So I multiplied by 2 and I got 0.0056. Because 0.0056 is less than alpha, I reject the null hypothesis. In the critical value approach, you said because 2.77 is greater than 2.575, you reject. In the p-value, because the p-value is less than alpha, you reject. Now a little bit additional information that I put here. Z value greater than 2.77 plus Z value less than minus 2.77 is this value. What does it mean? Given that the null hypothesis is correct, the probability that I would see these things, now who can tell me why do I write? Okay, let me explain a little bit. Maybe it is a little bit additional info. You see, if this one is 28.1 minus 225, what is the value? 28.1 minus 25 is 3.1. If you want to get minus 2.77, this value must be 21 point something, yeah? So that's why I put that. Because in a two-tailed test, it could be here or it could be there. There is a possibility 2.77 minus 2.77. That's why I put this one. But if you don't understand or you don't like this one, you could just simply ignore it. Eh? But to the right of 2.77, greater or equal, less or equal minus 2.77, I found 0.0056. In terms of X bar, if it is greater or equal to 28.1 or less than or equal to 21.9. 21.9 would give you minus 2.77. 28.1 would give you 2.77. So given that the null hypothesis is correct, the probability that I would see this kind of things is very small. It is highly unlikely. Then where is the problem? Why it is highly unlikely? The problem is not my sample. The problem is the null hypothesis was not correct. That's why I rejected it. Another thing connected to this one. Keep in mind the question that I gave you here. I will give you also with a different explanation. Eh? Keep the information that's given here. So let us try to expand a little bit and do a decision based on other things. We did a critical value, we did a p-value. I will give you another 2 ways of doing that. But it doesn't mean that you need to know everything to answer the question. Sometimes in your exam I will ask you, use the critical value, but tell me the p-value. What is the p-value for this? Okay. Recall our sample mean, 28.1. Recall our hypothesis, equal to 25, is not equal to 25. Recall our decision was reject the null hypothesis. Recall our critical values, plus or minus 2.575. Recall the standard error, 8.46, divide the square root of 57, 1.1206. We have this information. This is what we write. Now, this is the hypothesized value. What I want to calculate, this is a critical value. This is the Z value, isn't it? This is Z value. It could be 1.96, should be. So this, but I want to find the value. X bar, lower critical value. X bar, upper critical value. So I want to calculate this. Z calculated equals upper critical, X bar critical minus mu divided by the standard error. So I want, instead of this one, instead of minus 2.575, I want to put the number. I want to put X bar lower critical, X bar higher critical. That's what I want to calculate. So there is nothing that I am doing. Instead of these numbers, I would like, so minus 2.575, this is the hypothesized value, minus the standard error. I calculated 22.1145. For this one, 2.575, X bar upper critical, X bar lower critical. So far it is fine. We need this one in lecture 5. But what I do is simple. Instead of this one, I have X bar lower critical. Instead of this one, I have X bar upper critical. So this is lower critical, upper critical. Now, what is my decision? What is my decision for that question? What was my decision? Reject. My decision was reject. What was the sample mean? What was the sample mean? 28.1. I reject because 28.1 is somewhere here. I could possibly also reject if my X bar was 20. So anything to the left, reject. Anything to the right of this number is reject. Why do I reject? Because 28.1 is greater than 27.88. In my question, instead of 28.1, if I had 20.1, would I reject? I reject. 20.1 also is here. I reject because 28.1 is here. I could also reject if this one was 20. I could still reject. Shit. It's recorded, eh? So is it clear? We need this one when we do the type 2 error. Okay, so the reason why I reject is simple. Because this is a rejection area, this is a rejection area. So anything to the right of this one is rejection. 28.1 to the right. So this is also another way of doing that. Anything to the right of this one, reject. So I write here a small note. This indicates that our sample mean 28.1 is must be greater than 27.8851 or less than 22.1 so as to reject the null hypothesis. To reject the null hypothesis, it must be either this way or that way. Now, let me ask you to, for the same question, calculate the confidence interval. For the same question, let us calculate the confidence interval. So I am trying to calculate the confidence interval. Let us calculate the confidence interval. 28.1 plus or minus the critical value times the standard error. Isn't it? Point estimate plus or minus critical value times the standard error. I reject the null hypothesis, isn't it? If you reject the null hypothesis, the hypothesized value must not be in the confidence interval. If you reject the null hypothesis, your hypothesized value should not be between the confidence interval. If you don't reject, your confidence interval includes the hypothesized value. If you reject the null hypothesis, you reject the null hypothesis, so the confidence interval should not include the hypothesized value. If we reject the null hypothesis, the confidence interval should not include the hypothesized value. 25 is not included. Close, but not included. The same thing, 2.71 is close to 0.5. So this is also another way of doing that. So we did a critical value approach, a p-value approach. You could use this x bar upper critical, x bar lower critical. You could use confidence interval. Okay. Another example, past experience has shown that the scores of students who take a certain analytical statistics test are normally distributed, 75 variant. Is population standard deviation given or not? Yes, population standard deviation given. Do we apply Z or T? We apply Z. One tail to tail from the question. Always you have to see the question. Is it typical or not typical? It didn't say it is greater or less. It's saying that, so is it one tail or two tail? Two tail. Alpha is 10%. 5% to the right, 5% to the left. 5% to the right, 1.645. 5% to the left, minus 1.645. So I calculated 4.67. Because 4.67 is greater 1.645, I reject the null hypothesis. My conclusion would be at 10% level of significance, there is sufficient evidence to conclude that the population mean is not equal to 75. So if it were a one-tail test, we will probably also conclude the same way, but it would be greater than 75. The statistical decision is to reject the null hypothesis in favor of alternative hypothesis. There is enough evidence at 10% level of significance to conclude that this year's students are not typical. It seems appropriate that it is superior. Why do I say superior? Because the sample is very large than the hypothesized value. but the question was two-tailed. If you want to do a p-value, you take this 4.67 or greater, minus 4.67 or less, and then probably it would be very small, because minus 1.96 is 2.5%. So if you go for minus 4.67 to the left, is almost zero. In the table, if you go here, I don't know whether the table is here, sorry. Minus 4.60 something, almost zero. Minus 4 is zero here. So the p-value is almost zero. If the p-value is almost zero, could you reject at 5%? Because the question is 10%. Would you reject at 5%? Yes. Would you have rejected at 1%? Yes. Because this is very huge. Now it is unknown. The unknown, it is very simple. We apply a t-test. Don't forget the degrees of freedom. The only thing that makes a little bit different is how do you find the p-value? How do you find the p-value? The rest, it is the same thing. You find the critical value, you reject, not reject. It's the same procedure. The same formula would apply. Nothing is changed, the same thing. This is all the things, the same like z-test, but let's go to the question. A random sample of 16 emergency reports was selected from the files of an ambulance service. The mean time required for ambulance to reach their destination, 13.4. This is the sample mean. Sample standard deviation, 2.83. Can we conclude that the population mean is not equal to 12 minutes at 5% level of significance? Assume that the population is normally distributed. Why do I mention assume that the population is not? Is it important to mention? Is it important to mention this? Why? Because the sample size is less than 30. Sample size, the central limit theorem is saying that irrespective of the distribution of the population, if you have a sample size greater or equal to 30, then it will be normally distributed. If the population is normally distributed, we don't care about the sample size. But if the population is not normally distributed, then a sample size must be greater or equal to 30. So I calculated 1.98. Then I need a critical value. How many degrees of freedom do I have? I have 15 degrees of freedom. So I go to the table, 5%. Is it a two-tailed test? On the right, how many percent? 2.5% to the right, 2.5% to the left. Degrees of freedom, 15. 2.5%, degrees of freedom, 15. So this is the critical value. This is the critical value. The calculated value is here, 1.98. 1.98 is greater than or less than the critical value. What do you? Is it greater? The calculated value now, the test statistics value is 1.98 is somewhere here. So we don't reject the null hypothesis. What do we say? Always our conclusion would be there is insufficient evidence at 5% level of significance to conclude that the population mean is different from 12. We don't get sufficient evidence to conclude this one. What is the point of mentioning 5%? Who can tell me? Here in my conclusion, in my conclusion, I mentioned this 5%. Why? Why do I mention it again? I say that there is insufficient evidence at 5% level of significance to conclude that the population mean is not equal to 25 or 12. 12.
Suppose if it was 10%, if alpha was 10%,
Yeah, yeah,
not reject.
exactly. Things could be changed at 10%, but we are sure at this 5%. So everything what we are saying is based on this 5%. Because at 10% we might reject. At 10% maybe this one would be somewhere here. 2.135 could be maybe, the number might be here 1.05, the critical value. Now, it is two-tailed test. if we want to do the p-value must be multiplied by 2. But how do we find the p-value? From the t-table, because this is a t-table, this is a t-test. Always please keep in mind the degrees of freedom. How many degrees of freedom do we have? 15. What is our calculated value? So keep in mind, calculated value, 1.98, degrees of freedom, 15. So let's go to the table. Let me show you first. Degrees of freedom, 15. I tried to locate 1.98. I couldn't find exactly, but somewhere between this. So 1.98 is in between this value and this value. This is probabilities. Do I have to multiply this? We are doing two-tail test, isn't it? In a two-tail test, always we have to multiply. So we multiply this by 2. It would be 0.5. We multiply this by 2, it would be 10%. Because we say we don't reject the null hypothesis at 5%. So the p-value must be greater or equal to 5. If you don't reject the null hypothesis at 5%, your p-value must be either equal to 5% or greater. If you don't reject. If you reject, p-value must be less than alpha. If you don't reject, p-value must be greater or equal than alpha. So in our mind, our p-value, to the minimum, it must be 5 or more than that. So we are doing a two-tail test, and we say that we have to multiply by 2. So 1.9 is somewhere between these two values. I multiply this by 2 because I am doing two-tail. I multiply this one also by 2. Then I would conclude that my p-value is between 5 and 10%. My p-value is between 5 and 10%. If you say your p-value is between this and this one, why do you reject? If you don't multiply by 2 and you say to me, my p-value is between 2.5% and 5%, I will ask you, why do you say then you don't reject? You say you reject. If you say you reject, your p-value must be greater or equal to alpha, isn't it? To the minimum, it must be 5 or 6, 7, 8, 9, 10. And we are doing a two-tail test. Degrees of freedom, then locate the test statistics. The degrees of freedom is 15. The test statistics is 1.98. I am trying to locate. I found it is between here. Oh, this is the probability. This is the probability. Then I say to myself, oh, I am doing a two-tail test. So let me multiply this by 2. Let me multiply this by 2. It would be 10%, 5%. So finally, I would say, by the way, when you are using Excel or any other software, it will tell you exactly. But here, it doesn't tell you exactly because we are using the table. But if you are applying, in your tutorial, you will see it. The p-value would be maybe 7% or 6.5%. The Excel, the software will tell you. So this is how we will do. Always take the degrees of freedom and then the test statistics and try to locate. If the question were one-tail test, do we need to multiply this? We leave as it is. We would say between 2.5 and 5%. Now, let's go to the proportion. In the case of proportion, if the population is normally distributed, we don't care about sample size. If the population is not normally distributed, these things must be fulfilled. NP greater than 5, NQ greater than 5. We have to use the formula. Do you think this formula is a little bit different when we do the confidence interval? In a confidence interval, what do we use this one? P and Q must be P hat, Q hat. You remember when we do the confidence? Only for the confidence interval I said in my lecture. But that is different from this one. Eh? Okay. A manufacturing company believes exactly 8% of its product contains, this is the claim, the belief, 8% of its product contain at least one minor flaw. Suppose the company researcher wants to test this claim, this belief. The null, so it is different, this is already. The business researcher randomly selected a sample of 200 products, inspect each item for flaws, and determines that 33 use 10% level of significance, either to reject or not to reject. This is the population proportion. P hat is the sample proportion. So it is 10%, 5% to the right, 5% to the left. 1.645 minus 1.645. This is the population proportion. This is, so in terms of P hat scale and in terms of Z scale. So this is the hypothesized value, which is 0.08. This is what we find from our sample, 33 out of 200. Then I found 4.43. 4.43 is very far from 1.645. So not only at 10%, I could even reject at 5%. So because 4.43 is greater than critical value, I reject the null hypothesis, and it means that there is sufficient evidence at 10% level of significance to conclude that it's not equal to 8%. So the conclusion always, you could take from the question. You just say there is sufficient or insufficient evidence at this percent to conclude. The rest, you could pick it from the question to conclude that is not equal to conclude that this is not equal to 8%. So again, please, in your exam, because I showed you how to do using critical value and p-value at least, maybe the other things that I showed you, it is a little bit extra about x bar lower critical, x bar upper critical. And I try to show you also using a confidence interval, that's fine. But if you need to understand how to make a decision using the critical value approach, this is the critical value approach, and using the p-value. If you are using the p-value for a two-tailed test, you have to multiply by 2. For a one-tailed test, you don't need. Always compare with alpha. P less than alpha, you reject. P greater or equal to alpha, you don't reject. Okay, type 1 error, type 2 error. This is the last part. You remember type 1 error is clear. Alpha is type 1 error. The probability of rejecting the null hypothesis when it is correct. The null hypothesis is correct, but you reject it. That is a mistake. We call it a type 1 error. Type 1 error is given in any question. Alpha would be given. Type 2 error, we have to calculate it. And part of our lecture we don't have next week, part of our lecture next meeting would be how to calculate type 2 error. Because we don't need type 1 error to calculate. It is things that you allocate. You say that I could make a mistake and reject the null hypothesis while it is correct. You could make 1% chance. Could alpha be 20%? Do you give a chance 20%? A chance of making a mistake? No. You give a mistake only 1%, maximum 10%. You shouldn't go beyond that. Okay, so type 1 error and type 2 error. Type 1 error, you reject the null hypothesis when it is true. Type 2 error, you don't reject the null hypothesis when it is false. So type 1, reject the null hypothesis when it is true. Type 2, you don't reject when it is false. Again, it is a mistake. What do we call it? If alpha is 5%, what do we call it the 95%? The confidence, no, the confidence. So if you have 5% alpha, the rest will be the confidence. And if you have, let's say, 2% type 2 error, the rest we call it power. Okay. A type 1 error is committed by rejecting a true null hypothesis. You convict an innocent person of a crime. He is innocent, but you reject that he is innocent and you convict that person. A type 2 error is we fail to reject. We fail to reject means you don't reject the null hypothesis when it is false. You fail to convict a guilty person. The person is guilty, but you say that I didn't find any evidence. So that way you could. So this is so if type 1 error is 5%, 95% would be confidence, the confidence interval that we do. If type 1 error alpha, type 2 error beta. So this is usually in textbook, you will find alpha, type 1 error, beta, type 2 error. If type 2 error is 10%, then the power would be 90%. If the type 2 error is 30%, the power would be 70%. You couldn't, we will talk a little bit more about type 1 and type 2 error, because if you reduce the type 1 error, then indirectly the type 2 error will increase. If you reduce the type 2 error, then the type 1 error will go up. But the main thing that you want to keep both at the minimum if you have a very big sample size. So this is simply an example. I am right and was tested wrong, everything fine, but wrong. This is a mistake. Here also I am wrong and was tested right. This is also a mistake. Here I am right and was tested right. I am wrong and was tested wrong. So this is a correct decision. This is an error. Okay, next week we don't have a lecture. So next week, no lecture, but you have tutorial. We will cover this lecture's tutorial. Teaching week 6, yes, we have a lecture, lecture 5, but you have tutorial. You have tutorial in teaching week 6, but there is no new material because I don't have any lecture. You don't have new material. What I will post on Blackboard is, revision questions from lecture 1 to lecture 4. I will send you, and then please try those questions, and the tutors will answer. Tutors will show you how to answer. 1 minute. So please keep in mind, next week there is no lecture, but you have a tutorial. Then teaching week 6, there is a lecture, but your tutorial, it's not a new material. We will be a revision 1 to 4. 1 minute. Again, please. Only half a minute. Okay, we will. 1 minute. Okay. So the mid-semester exam, so before a week, 1 minute, 1 minute, 1 minute. So these are all, there is no multiple choice here. These are additional workout questions. So you will do all these things with the tutors during tutorial hours. But for the multiple choice part, I have a mid-semester exam practice MCQ, which is very much similar to my MCQs in your mid-semester exam. I will release those questions a week before the exam, so you practice again and again, because the questions could be randomly changed somehow. So try again and again. So there is unlimited period to try those questions. And the formula sheet also will be released a week before the exam. That formula sheet would give you an idea. If there is no big formula in that formula sheet, then you would suspect there is no question of that type. So that might give you a little bit how the questions would look like. So anyway, next week we will not meet. So thank you. Yeah, bye.